Good day everyone, I am Bernafe E. Abilia and in this video we will going to conduct an experiment titled Matter in a Minute Particle. Anything Before anything else, for any laboratory activities, always make sure to wear your lab gowns properly, your safety gloves, your safety goggles, and for girls, please tie your long hair for safety purposes during laboratory procedures. Thank you. Materials we need for this experiment are the following: 3 empty bottles labeled with A, B, and C, water, and sand. But before we conduct the proper experiment, let's have first a 2-bottle cap, and uncapped bottle. And I'm going to squeeze it with my hands and observe what happens. So as you can see, the uncapped bottle can be squeezed easily, while the capped bottle is very hard to squeeze. Do you think the bottle is empty or not? Actually, the bottle is not empty because there is air inside composed with gas molecules. And always remember that gas is the third state of matter. So now, let's proceed to our proper experiment. So I have here 3 bottles labeled A, B, and C. Empty, filled with water, and filled with sand. So now let's put a balloon on top of each bottle. Okay, so make sure the bottle A is empty and make sure that you secure tightly the bottle B and as well as the bottle C. You need to secure it tightly. So now I will going to squeeze each bottle and observe what happens. So the balloon inflates a little because the bottle contains air, which is a mixture of gas. And the gas in air contains or composed of gas molecules. So when the bottle was squeezed, the gas molecules move from the bottle towards the balloon. For bottle B, I will try to squeeze the bottle filled with water. So see what happens. So the balloon inflates with water because when the bottle was squeezed, the water molecule moved towards the balloon from the bottle because the balloon has free space to occupy with. That's why the water molecules inflates the balloon. You can see, I can still squeeze the bottle filled with water, but not as much as I can squeeze the bottle filled with air because the molecules in water are very close to each other. Unlike in the bottle filled with air, the molecules can move freely. That's why I can squeeze it very easy. So as you can see, the balloon does not inflate or does not fill with air because the molecules in the sand are very close or very compacted and to the point that there is no space for the sand molecules or the solid molecules to move towards the balloon. That's why it does not inflate the balloon. And it's very hard to squeeze, unlike the two, which I can squeeze much easier than this one. No, because the bottle was filled with sand that are very compacted. Its molecules are very close to each other, and so the bottle is very hard to squeeze. As you can see, the bottle is very hard to squeeze. So liquid has a definite volume and take up the shape of the container. Liquid vibrate and can move about and slide past each other, while the gas molecules has no definite shape or volume and so it moves freely at a high speed. So you can see the difference. You can see the difference. The closed bottle of a gas is much easier to squeeze than the closed bottle of a liquid because the gas has no definite shape and does not take up the shape of its container or of its bottle, while the liquid has a definite shape and takes up the shape of its bottle or its container, and plus there is no air inside, unlike the gas bottle. That's why it is very hard to squeeze the closed bottle of a liquid than the closed bottle of a gas. See the difference. So that would be all. Thank you. And I hope you learned something from this video about the different behavior of the three states of matter: the gas, liquid, and the solid. So, bye!
Good day, everyone. I am Novami Pagaling Elsa from BSN Sciences 3. In this video, we will to conduct an experiment entitled Matter in Motion, in which we will to determine the different speed of molecules present in hot and cold water. But before anything else, please note that in conducting in any kind of experiment, we should always wear our lab gowns, our laboratory gloves, and our safety goggles to protect ourselves from different chemicals inside the laboratory. And for girls, we should always tie our hair to avoid distractions. The materials that we need in this experiment are hot water, cold water, yellow and blue food coloring, and two droppers. At the end of the experiment, we will able to answer the hypothetical question of this experiment, which is the speed of the molecules different in hot and cold water? So now, let's proceed to the proper experiment. At this point, we will to transfer or put food coloring into our water and see what happened. And we also put blue food coloring into our water, into hot water. Add some into our cold water. After we conduct our experiment, observe what happens to your experiment and record that you have gathered into your laboratory notebook. We will now answer the discussion questions. So first,
Molecules moving faster in hot or cold water.
with an increased temperature, the particles will gain kinetic energy and will tend to move faster. The temperature has an effect to the speed of the molecules in any kind of matter. It could be in a form of gas, liquid, or solid. So as we can observe in our experiment, warm water has more energy than in cold water. Thus, the molecules in hot water or warm water are moving faster and move farther apart from each other due to its temperature. So now we can say that the molecules in warm water are moving faster than in cold water. Now we should answer this second question.
What does the speed of the mixing colors tell you about the speed of the molecules in hot and cold water?
The yellow and blue food coloring are spreading faster in the hot water than in cold water. So it simply means that the molecules in hot water are moving faster, bounce off each other, and moving farther apart than in cold water. The faster moving molecules of warm water bump into the food coloring molecules that makes the two food coloring combine and turn into another color, which is green. While in cold water, the slower movement of the molecules makes the food coloring to separate or to remain separate for a longer period of time. So now we can conclude that heating a liquid increases the speed of the molecules. I hope that you have learned something new from this video. So have a nice day ahead, guys. God bless everyone.